Welcome to this edition of Open-SCAD by DIY3DTech.com. In this episode, we're going to take a look at building a component stand. Actually, I'm building this for a tube buffer on my hi-fi system. However, one of the things that I did want to share, actually there are two major things with this build that I want to share that I've done, which you guys might find interesting. And one of the first is I wanted to match the chamfer of the inside curve with the outside curve, because one of the things, if you do this in sort of something like Tinkercad or Fusion 360, we just wrote blocks and in combining primitives of say a rectangle and circles, you won't be able to match this offset, and this is part of the key. The other piece is these openings that actually mount the feet. So one of the things I've done is you can see here is I've modeled the actual feet, and what they do is they taper. So what happens is the foot presses in here and becomes a press fit into this whole bracket, and this is what really kind of holds everything in place. So I thought this was kind of a neat concept. Now I've made it semi-parametric over here where you can set the different settings, and the code will be out on the website with the link below. So if you want to pick it up and design your own feed for your own stereo equipment or any type of electronic or home entertainment system, you're welcome to grab it. However, one of the things I kind of want to jump down in here is how did I do this? So one of the big pieces is, first off, I started out making this a 2D object. So one of the things I did is down here is I had stolen this code off the internet, and it was originally meant to create a rounded cube. However, what I did is I replaced the cylinder function with that of a circle and the cube with that of a square to create a 2D object, and then what I did is I dropped the z-axis up here. Now, why is this important? Well, when I call it up here, one of the things I do is obviously linear extrude the object, but what I also do is I create an offset for this. So my difference is going to be from the inside is going to be the offset. So here what I do is I linear extrude this object, this what starts out to be a flat object, from rounded. And so the original is created up here, and then I offset and I take out, subtract the difference with this. But what I do is I use the offset command right here. So as you see right here, so I use offset delta equals offset. So my variable is offset, so I can set how far I want this to be smaller on the inside. Now when I call delta, what this means is I want it to match the exact curve of the outside. And so if I actually, let's just go ahead and pop this in and do this, take a look. So you can kind of see the square now over here, and you see how it matches this. And this is achieved over here by utilizing the delta. And then what I do is up here is I call offset by 4 millimeters. So that means my thickness here will be this number, so it is going to be 4 millimeters. So if I want to make it 6 millimeters, I can change that. You can see it thickens it up a bit. So I'm going to go back to 4, and so that's a pretty neat function. And again, you can only call this with a 2D object that you've extruded. So this makes it really nice if you want to match the curves, and it makes for sort of an elegant looking sort of stand, if you will, at least in my opinion. So again, I want to remove this and then go back, and I want to talk about these. So down here in these two pieces is where I translate. I just simply use a cylinder command here and here to create the two cylinders. I utilize an offset of the distance, splitting the distance in half between here and here for my origin. And then obviously I take the measurements from the device, and what happens is, again, since this is tapered, the feet fit inside the taper. So let's go ahead and maybe we can see this. I'm going to remove one of these, and so we'll take a look. So you can see a little bit of the taper here. So it's bigger at the top, gets smaller at the bottom, and then what happens is as we'll see, is the foot locks into it. So with this, what I do is let's jump into a time lapse of one of these being printed, and then let's go over to the bench and actually look at it all installed. So we'll catch you over at the bench. Okay, welcome back. So we took a look at these in the computer in Open-SCAD, talked about them a little bit. We saw one being printed out in time-lapse on the printer. Actually, it's very cool how, again, it prints these circles out or these voids with no infill, so it's pretty exciting. So also what I'll do is up in the corner, and probably as an overlay, I'll show them actually installed. They're a nice tight fit onto the feet because remember, one of the things we did is we recessed this, or not really recessed it, but angled this to match the foot, so the foot actually slides in there and sticks. So these are elevated. Also, this is pretty strong, which is really impressive. And we also have a nice bend in here that matches the outer bend. So aesthetically, they're very attractive. The prints came out very nice. And as you can see, as I swipe over, how they look actually installed on the buffer. So anyways, hopefully you found this build interesting. If you did, hey, give it a thumbs up. Don't forget the swag shop in the upper corner. Helps us out. Also subscribe, and we'll see you in the next time.